Okay, so welcome everybody to class today. Now that we're recording, can you please type your name into the chat so we have a record of your attendance, so we know to send you the data next week. Next week we'll meet back at the regular time, back at 4:30. I've had a couple of meetings last week and this week, so I had to move things back. Okay, so welcome everybody again. It's good to see you here. I hope you had a good week. You're in good health. I hope your family is good. And yeah, so we want to talk a little bit more about statistics. We're getting toward the end of the statistics unit. And today we basically have finished talking about the visual presentation of data. And we'll do an example of that today for the homework, and then we're going to go on to more computational things. Okay, so we're going to get away from the visual presentation and more onto the computational presentations. Okay, so first I want to just go over the homework. So let me just mute everybody. So feedback. So for the homework, we had 3 questions about the same data set. Right, so one was using the frequency table from slide number 9. I'll show you what that table is. We want to add in columns for regular relative frequency and cumulative relative frequency, right? So the data table was over here. I've reproduced it, and what the homework question asked you to do is to add on a column for relative frequency and for cumulative relative frequency. Okay, so we want to add on a column for relative frequency and cumulative relative frequency. So does somebody want to do the relative frequency part? How do we figure out the relative frequencies to put in this column? So the first thing we need to do is figure out the total number of measurements. So how do we figure that out?
We found the sum of the frequency.
Yeah. So what is that in this example? What calculation do we have to do?
2 plus 4 plus 3 plus 3.
Mm-hmm. Great. So
plus,
total number.
Plus 2.
Great. Thank you, Christopher. Okay. So that's exactly right. So the total number of measurements, as Christopher said, is 2 plus 4 plus 3 plus 3 plus 2 plus 3 plus 3. This turns out to be 20. Okay. So for each relative frequency, right, we have to divide the absolute frequency by the total number of measurements. So we get the relative frequency by dividing everything by 20 over here, right? So here we have 2 divided by 20 is 0.10, 4 divided by 20 is 0.20, right? This is 2 divided by 20. This is 4 divided by 20. 3 divided by 20 is 0.15. 3 divided by 20. So I'll fill in the rest of the table. 0.15. 2 is 0.10. That's 2 divided by 20, and then we have 3, and then another 3, so 0.15 and 0.15. Okay, so this is our column for relative frequency. So for the cumulative relative frequency, does anybody want to fill in the last column for me? So you can just tell me what numbers we should be putting in the last column for the cumulative relative frequency.
We can begin with 0.10.
Mm-hmm.
So 0.10 will be the first number. The next number will be 0.10 plus 0.20.
Right. Good. So 0.30, right? That's 0.10 plus 0.20. Mm-hmm.
We add 0.30 to 0.15.
Great. And
then we add 0.15, that will be 0.60.
Right, exactly. And then
0.70.
Mm-hmm.
0.85.
Mm-hmm.
That would be
1.0, exactly. So I'll just fill in again. How did we get all of this? If you missed it, you're always just taking the previous cumulative relative frequency and then adding the measurement for your row. So this is 0.30 plus 0.15, 0.45 plus 0.15, 0.60 plus 0.10, 0.70 plus 0.15, and then 0.85 plus 0.15. That's how we figure all of this out. Okay, any questions about how we fill in this table? Okay. So, all right. So if there's no questions, let's go back to, so question number 2 is to construct a histogram for this data as well as a cumulative relative frequency plot. Okay. So the histogram at this point, we know how to do histograms. So I'll just write it down. I'll just do this by hand because it'll be a little bit easier. So let me just add a page. We're going to do a histogram by hand, which is going to have over here, I'm still letting people in. So over here, we're going to have the score. And then over here, we're going to do relative frequency. Okay, and so we see you don't have to start your histogram at 0, right? So in this case, our numbers start with 4 and end with 10, so we can do a range of 4 through 10 for the histogram. And so for this histogram, we'll just have 1 bar for each score. Okay, so I'm just going to mark over here on this axis. Let me try to draw this corner a little better. I'm going to mark 4, 5, 6, 7, 8, 9, 10. And if we have relative frequencies over here, it looks like there isn't such a big range, right? Everything just goes from 0.10 to 0.20. So maybe what I'll do as a scale is I'll mark, sorry, I'm just going to mute everyone. So I'm going to mark 0, and maybe we'll mark every 0.05. So 0.05, 0.10, 0.15, and 0.20. These will be the heights for our bars. And then I'm just going to draw the bar. So 4 was, we had what? 0.10, 0.20, and then 0.15. So this was 0.10 for 4, 0.20 for 5, and then 0.15 for 6. And then 7 was 0.15, 8 was 0.10, and 9 was 0.15. So we'll have another 0.15, and then 0.10, and then 0.15. And then lastly, 10 was 0.15 also. So 10 was 0.15. Okay, so designing the histogram is relatively straightforward. Of course, I've done a bit of a sloppy job. If you were doing this carefully, all of these columns should be the same width. The way I've drawn it, this one looks a little narrower than this one, but that's just a mistake because I'm doing it quickly. If you want to do a careful histogram for presentation, you want to make sure that all of the columns are exactly the same width. And if you do it on one of these computer programs like Microsoft Excel, it will guarantee that for you automatically. So now what we want to do is this cumulative relative frequency plot. And if you remember how I showed this for you on Excel last time, what you have to do for this is make another axis, which I'll make in a different color. I'm going to make another axis on the right side over here. Let me try to draw this. Let me try to draw that a little straighter. Okay, it's still not that much better, but let me try this. All right, that is better. Okay, nice straight line. And on this axis, we're going to have the scale of cumulative relative frequency. So I'm going to write it in this color, in red. So cumulative relative frequency. And this scale has to end up going to 100%, right? So maybe I'll mark this, maybe I'll mark it every 20%. So 0.20, 0.40, 0.60, 0.80, and 1.00. Okay, so I'll mark it every 20. And then remember what we do here is we look at the cumulative relative frequency for each of our classes. In this case, our classes are just individual measurements, and we mark it in the appropriate bar. So for 4, the cumulative relative frequency is 0.10, so we mark it inside the 4 bar. And then the 0.30 we mark inside the 5 bar, and so on. So for 0.10 inside the 4 bar, that's going to be here. And then 0.30 in the 5 bar is going to be here. And then what do we have? We have 0.45, 0.60, and 0.70. So 0.45 is going to be maybe here. 0.60 is going to be here. 0.70 is here. And then we have what? 0.85 and 1.00. So 0.85 looks like it's going to be maybe up here. And then 1.00 is up here. And so we have all of these markings. And then what we do is we draw a straight line in between each of these. And connecting those straight lines, that is our cumulative relative frequency plot. Okay, so the cumulative relative frequency plot is going to be ideally in a different color than the rest of the histogram, and it uses the scale of a different axis, okay, which is measuring cumulative relative frequency, which always goes from 0 to 1, right? 1 is always the cumulative relative frequency of the top class, and it starts at 0, and then you measure it just by drawing lines connecting these dots that are for each class. Now here, the dot isn't in the bar because my scale over here is bigger than my scale for this bar, but that's fine. This dot is still directly over the 10 measurement, and this dot here is still directly over the 9 measurement, and this dot is directly over the 8 measurement, and so on, and that's giving you the cumulative relative frequencies of the individual classes. Okay. Any questions about this? Okay, so the third homework question was to calculate the 60th and 70th percentiles for the data, okay? And if you remember last time, we learned a method for how to calculate percentiles, which we called the accumulation method, okay? So I'm going to include this slide over here, which is just a review of how we calculate, which is a review of how we calculate this, okay? All right, so the review of how we calculate the percentiles, if we have a data set with n entries, so in this case, we have n equals 20, right? N equals 20 for our data set. And we want to calculate the pth percentile. So here it's going to be p equals either 60 or 70, depending on the question. So first, we're going to arrange the data in ascending order. So we go from smallest to largest. And then we have to calculate the rank, right? We have this preliminary calculation where you take the number of measurements plus 1, and then you multiply by the percent, right? Like if it's a 60th percentile, you multiply by 0.6. If it's a 70th percentile, you multiply by 0.7, and so on, okay? And then if you get an integer, you just take the rth data entry. But if r is not an integer, then you have to do one more calculation, right? One more calculation, which is you look at the r and the r plus first data entries, and then when you take the fractional part, you take the fractional part of this, and then instead of just taking the rth entry, which is x, you have to add on a little bit corresponding to this fractional part times the difference of the two entries. Okay, so let's do this for the data that we have. I guess I'll need to go to another page because we don't have enough space. So let's do another page here. So let's say we got 60th percentile. Okay, so the 60th percentile, right? We always have n equals 20. That's our measurements. And p is going to be 60 because we're doing the 60th percentile. No, p is 60. So we first calculate this rank. So R is going to be 60 divided by 100 times 20 plus 1. This is the same thing as 3/5 times 21, which is equal to 63 over 5. And if you write this as a decimal, this is 12.6. So now we have to write out the data in order to try to find what the 12th entry is. And we want to also, we may also need to know the 13th entry, right? The 12th and the 13th, because we have 12.6. So the data, which we have to write out, is coming from the chart, which means we've got 2 4s, 4 5s, 3 6s, and so on. So we have to write 4 4, 5 5 5 5, 6 6 6, 7 7 7, and so on. So the data is going to be 4 4 5 5 5 5 6 6, I think 3 6s, 7 7 7, and then what was next? 8 8 9 9 9 10 10 10. Okay, so 8 8 9 9 9 10 10 10. Okay. So now, so what do we need? So the 12th entry, so X is the 12th entry. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 7. And then the 13th entry is 8. So X is equal to 12th entry is 7. Y is equal to the 13th entry. This is 8. And so now we have to use the formula. So 60th percentile. So the 60, I wrote a percent sign and then ile, that's percentile. So 60th by the formula is X plus F times Y minus X. In our case, F is equal to 0.6. It's the fractional part of the rank. And so this is going to be 7 plus 0.6 times 8 minus 7, which is just equal to 7 plus 0.6 times 1, which is equal to 7.6. Okay, so the 60th percentile of this data is 7.6. Okay, so I did this one. For the 70th percentile, I'll have one of you do it. But before that, are there any questions on how I did this computation?
Yeah, hello, sir.
Yes, Princeton.
Yeah, I wanted to really get why you got the X, you got the 12 tenths, because you talk about 60 tenths and 70, but yeah, I'm saying 12 and 13 tenths entry.
Right. So if you look at the method here, what I called X here is the rth data entry, and Y is the R plus first data entry. So we calculated this R, which was 12.6. So sorry. When I say the when I say the rth and the R plus first, I should say R is rounded down. Sorry, I forgot to say that. So it's rounded down. So if our rank here is 12.6, then X is what happens when you round down. It corresponds to the 12th data entry, so that's 12. And Y is what happens when you round up. It's what corresponds to the 13th data entry. So the 12.6 means we look at the 12th and the 13th, and then we just count from the beginning until we get to the 12th one. In this case, the 12th one was 7, and the 13th one was 8. Is that okay?
Okay. For round of 12.4.
So sorry.
Hello, you getting me, sir?
Yeah, I'm getting you now. Now I'm not getting you. Now you seem frozen.
Yes.
Yes. Armstrong?
I want to understand something.
Yes.
How do
Hello?
you get the
Hello, sir.
4
Sorry, Armstrong,
and the
yes?
5 there, like 4 times?
4 times. The 5 is because this is the table, right? So the table says the score 4 appears with frequency 2. And the score 5 appears with frequency 4. So there's 4 5s. And 6 appears with frequency 3, and so on. Right.
It's understood.
Okay, great.
Yeah. I was still asking a question, but I don't think you get me clearly, sir.
Okay, yes, Princeton?
Yeah, I'm saying that you said we round down and round up, but
Yeah.
then the rounding down I have it clearly, which is 12. But if for instance the number is 12.4, how was
Yeah.
the value of y going to be?
You still round down and round up. So for 12.4, it would be exactly the same. It's still the 12th entry and the 13th entry. The only thing that changes with 12.4 is that the F would be different. The F would be 0.4 instead of 0.6.
4, yeah.
But the entries, the X and the Y would still be 7 and 8 for 12.4.
All right, thank you, sir.
You're welcome. Other questions? Okay, so let's do the 70th percentile for the same data. So I don't need to write down the data again, and I don't need to write down n again because it's still 20. What we have here is that p equals 70, right? So how do we figure out r in this case?
That would be 70 over 100 into 70 over 100.
Yep.
Into 20 plus 1.
Exactly.
So that will be 7 over 10 of 21.
Yeah. This turns out to be, I think, 14.7 if you do it out.
So in the case, then our F is 0.7.
Yeah. Yeah.
So
F is going to be 0.7 exactly. So F is 0.7.
So if we round down, then our X is 12, 13, if we round down, our X would be 8.
Yes.
So it would be the 8th entry.
Yeah.
No, the 14th entry will be 8.
Right. So I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's the 8.
And if we round up, Y would be 9.
Exactly. Great.
Yeah. So we can now see.
So we get 8 plus
0.7 into 9 minus 8. So that will give us 8.7.
Exactly. All right, so there we are. Perfect. Okay, so that's going to be 8.7 in this case. Perfect. All right, any questions on this example? And so, okay, so if there's no questions on this example, if it's clear, then I want to make one comment that I made last time, but that percentiles and cumulative relative frequency are very related to each other. And in particular, if the cumulative relative frequency of a class is p, then the 100 times p percentile of the data. So like if p is, 0.6, then if you look at the 60th percentile, that's what 100p is. That should be roughly the maximum in that class. Okay, it's not going to be exact, but if you have a really big data set, like hundreds and hundreds of data points, then it will be very close to exact. So if we do this with this homework, so let's look at the cumulative relative frequency 0.6, and this should correspond to the 60th percentile. Now, we already calculated the 60th percentile. We already calculated that it's 7.6. But let's look at where we have 0.6 as cumulative relative frequency. So 0.6 for cumulative relative frequency happens at the score 7, right? And so that means we should expect the 60th percentile to be close to 7, okay? And in this case, it is, right? I mean, it's 7.6. It's not exactly 7, but it's pretty close to 7. So cumulative relative frequencies can give you rough approximations to percentiles. Okay, so if I see 0.70 is a cumulative relative frequency and it's in the row for 8 as the score, that means the 70th percentile is going to be about 8. So in this case, it's actually a little bigger than 8. It's 8.7, but it's a rough guide. Okay. So the 30th percentile should be about 5, right? So this will generally give you will generally give you a rough guide, and that makes sense because the 30th percentile is saying, well, 30% of the scores are 4s and 5s, right? So that means about 30% of the scores are less than or equal to 5. So we expect the 30th percentile to be about 5. In fact, here, the 30th percentile falls somewhere between the 5 and the 6 because you use this interpolation method. But in any case, it's always going to be very close. Okay, so any questions about any of the percentile calculations here before we move on? Okay, all right, so okay, so if there's no questions, let's move on to the new material for today. So this is something that if you were in the class 2 years ago, it's going to be a repeat. We're talking about these measures of central tendency. Okay, so maybe that's an important enough phrase that I'll write it at the top of the slide. So measures of central tendency. Okay, so we talked about this a little bit in April of 2022, if you were in the class then. But I think a lot of people are new since then, so it shouldn't be too much of a repeat. So what's the idea? Suppose that we have a finite set of data entries, so like x1, x2, all the way up through xn, okay? So these data entries are not just random numbers, they're drawn from some distribution. They might be test scores in a class, or they might be, weights of babies in a hospital, or they could be, they could be anything, but they're all supposed to represent the same kind of thing. And so the idea of a measure of central tendency is to try to understand, what is kind of the expectation? What do we think is like the most representative number for this data set? Like if I wanted to summarize the entire data set using only one number, what would that be? Okay, and it turns out that there are lots of different ways of doing this and different ways that are sometimes appropriate depending on what kind of data you have. So the most common one is what's called the arithmetic mean, or sometimes it's just called the mean, or sometimes it's also called the average. So people use a lot of different words to mean the same thing. And what is this given by? Well, your formula is you add up all the data, and then you divide by the number of entries. You divide by n. This is the average, okay? Another time, sometimes the average can actually be misleading. We'll see an example of that. And it's better to use what's called the median. So the median is the data entry that occurs in the middle of the sequence of data when everything is arranged from lowest to highest. So you take the middle entry, and if n is even, if you have an even number of data entries, then the median is the average of the two middle entries. And in fact, it turns out that the median is exactly the 50th percentile if you use this method we've been using. So if you use this interpolation method and you calculate the 50th percentile, it's going to be the median. It's going to exactly be the median. And then the mode, which is, people use it, but it's maybe, I would say it's less important than the mean or the median. The mode is the entry that occurs most often. And if there are multiple such entries, so if you have two different entries that each occur most often, then we consider both of them the mode. But if every entry occurs equally often, then we say that there's no mode at all, okay? And so all of these terms are what's called measures of central tendency. And the idea is that they're all reasonable numbers that might represent what a standard instance of your data is likely to be. So if you're measuring the heights of people, then, a standard measurement might be 5.5 feet or, 150 centimeters, something like this. Whereas, even though people will vary around that, a standard measurement would not be 8 feet or, 220 centimeters. Okay. So let's do some calculations with this. So let's say we have a completely standard data set, 1, 2, 3, 4, 5, 6. Well, we can calculate the mean. This is very straightforward. There's 6 data entries, so I just take 1 plus 2 plus 3 plus 4 plus 5 plus 6, divide it by 6. Turns out when you add this up, we get 21 divided by 6. And if I turn this into a decimal, this becomes 3.5. Okay. We can also calculate the median. Okay, so the median is, I just have to look at this. In this case, there's an even number of entries, so there's not one middle entry, but in fact, both the 3 and the 4 are the middle entries. And so to calculate the median, I have to take the average of the 3 and the 4, or the mean of the 3 and the 4. So the median in this case is just going to be 3 plus 4 divided by 2, which is 7 divided by 2, which is again 3.5. So in this case, the median and the mean are the same. That's not always going to be the case, but for this data set, it happens to have the same median and mean. And then the mode, well, there's not really any mode here because every entry occurs once, so everything occurs equally often. So in this case, we would say there's no mode. Okay, so this is a basic example of how to do these calculations. Any questions on this example? We're going to get to more difficult.
Hi, Dr. Upton.
Yes.
Hello, Dr. Upton. I really do not have question on this example because we have 2 set of data. We have the group data and we have the on-group data. For this one, it's on group. So find so we ought to find the means like this. But what if we have the data like group? Like for example, we have 4 students score from 70 to 75. 8 students score from 80 to this grade. That's a group data. How can we find the means?
That's a good question. Let's answer that next week. Okay. If that's okay. So if we have group data, we won't be able to find an exact mean in that case. We're going to have to find a approximate mean because we don't have the exact data. Yeah, so it'll be an approximate mean, but we'll talk about that. Let's do that next week. That's good. I wasn't going to do that, but I think it's a good topic. So let's do it next week. Okay. Other questions?
Yes.
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 Who's speaking now? Sorry.
Can a median be random of the nearest whole number?
Sorry, say it again.
Can a median be random of the nearest whole number?
Can a median be, sorry?
Random up to the nearest whole number?
Yeah, I mean, it can be a whole number. It can be a whole number. It can be not a whole number. It can be, median has a lot of flexibility. Yeah. The range is not a measure of central tendency. So I see a question in the chat. What about the range? So we'll talk about range when we talk about measures of dispersion, but the range is not a measure of central tendency. Okay, so let's look at a slightly different data set. So the exact same thing, but instead of 6, we have 600. Okay, so now we're going to get very different things. So the mean, we calculate same thing, 1 plus 2 plus 3 plus 4 plus 5 plus 600 divided by 6. And so when you add this up, this is 615 divided by 6, and this turns out to be 102.5. Okay. The median, on the other hand, well, I still just look at the 2 middle entries. And so oh, sorry, William, yes, question? Oh, sorry, can you round it up to 4? You should not round it up to 4. I mean, unless you have to round to a whole number, I would not round it. You shouldn't round it unless for some reason you have to, like somebody is asking you for the nearest whole number. I would not round that mean, that median or that mean. So sorry, William, question? Sorry, William, your hand is up?
Hello, sir. Yeah, sir.
Yeah.
Yeah, for the past question you solved, where you got a mode to be, okay, yeah. Where you said the mode is 0. Okay, you said no mode. But for instance, if you don't have mode, can you say the mode can be 0? Will it be possible in our phone?
No, you should not say the mode is 0. The only other thing that you could say here, or you could say that the mode, if you really wanted to, the mode is 1, 2, 3, 4, 5, and 6.
Okay.
Yeah, no mode is not the same thing as mode equals 0. So in this case, you really have to say no mode, because the 0 isn't even a data entry here. So it would be misleading to say that the mode is 0.
Okay, thank you, sir.
You got to say no mode. All right, you're welcome. Other questions? Okay, so here for our median, right, it's exactly the same calculation as before. 3 and 4 are still the two middle entries. So it's still just going to be 3 plus 4 over 2, which is 7 over 2, which is 3.5. Okay, and the mode, same as before, no mode. Okay. And so let me just make an observation. Here, the mean is much bigger than the median. Mean is much bigger than the median, and this happens when you have large, what are called outliers. Okay, so if you have a few entries that are much, much larger than all of the other entries, then that's going to change the mean a lot because it's going to go into the average, but it won't affect the median at all. So something that we can take away from that is that the median is less sensitive to outliers than the mean is. Okay, so when is it better to use the mean? When is it better to use the median? Well, there isn't a rule that says one is better than the other. But for instance, if you think that your data is going to have a lot of outliers that you don't really want to consider, you don't want them to affect the data, then then maybe it's better to use the median than the mean, right? I mean, there's a joke about this, right? Like 10 people are in a room, and then, Elon Musk walks into the room and everybody's happy because the average wealth in the room just got much bigger, right? But the median wealth in the room didn't get any bigger, right? Because Elon Musk is an outlier. So he's going to be much richer than everybody else. And he's going to do, it will affect the average, but it doesn't really affect the median. It doesn't affect most of the people in the room. So if there's outliers in your data set, sometimes the median can be a better approximation than the mean to kind of what you really want to understand about the data. What is the number that's really giving you the central tendency of the data? Okay, so any questions about this example?
Hello?
Yes, is that Harrison?
So in addition, it simply means that the means and median are quite different components of the data given, right?
Yeah, they're telling you different things about the data, right? The median is just telling you kind of like, if you think of the data as representing people, the median is just telling you like, what happens for the middle person? Whereas the average is taking into account also kind of how far away the different people are. So
thank you.
Yeah, so they're not measuring exactly the same thing. And sometimes it's better to use the mean, and sometimes it's better to use the median. All right, other questions?
Yes.
Yes, James?
Yes, in case you have more than T numbers at the middle.
Sorry.
Hello?
Yeah, sorry. I didn't get you so clearly.
Hello?
Yes, hello? Hello? If it's hard to hear, maybe you can type your question into the chat. Okay. All right. Well, I'll move on, and if you want to ask your question at some point, I'll type it into the chat. You can type it into the chat, and I'll answer it. Okay, so here's an example problem. This is more kind of a math problem than a statistics problem. So can we come up with a data distribution that has median 10, but mean equals 3? Oh, why if there are, okay, so sorry, James asked the question. What if there are 3 numbers in the middle? Well, the point is, if you have, maybe I'll write this over here. So if you have even number of entries, then there will be 2 in the middle. If you have an odd number of entries, then there will always be 1 in the middle. Right? So for example, if you have like 1, 3, 5, 7, 9, this is an odd number of entries, then there will always be 1 entry that's right in the middle. In that case, that's the 5. Okay, so I mean, there are also 3 numbers in the middle. You can take 3, 5, 7, but for the median, you only take the 1 number in the middle, and you just use that. So you can always use either 1 number or 2 numbers. You never have to use 3 to calculate the median. You could make a new measure of central tendency if you wanted to, called the 3 median, where you take the 3 middle entries and you average them. That doesn't really have a name, but it would also be a measure of central tendency. But for the median, you're just going to be using the number in the middle, or if there's an even number of data so that there's 2 numbers in the middle, then you take the average of those 2. Okay, so let's go to this problem. So can you come up with a data distribution that has median equal to 10, but mean equal to 3? So it's asking you to write down the numbers so that this happens. And well, if I want the median to be 10, probably I want to start with a 10 to be right in the middle. That's going to be the easiest way to have the median be equal to 10. Okay. So now if we want the mean to be 3, we're going to have to somehow add some more data, right? Because if the only entry I have is 10, then if the only entry I have is 10, then the mean is going to be 10 and the median is also going to be 10. Okay. So what could I do with this if I wanted to try to throw in some more data that would result in the mean being 3? What's maybe an idea for where to start?
Well, you can, let me try.
Yep. Sorry, Gabriel?
Kiro. Yeah.
Yep.
So since thing is already in the middle, let's try 1.
Mm-hmm. So add a 1.
2.
Yeah.
1.
Yeah.
Then on the other side,
Yep.
come after the 10.
Yep. So after the 10.
Another 1.
Oh, okay. But the problem is, right? Okay. So so I see what you're doing here, right? So here we have 1 plus 2 plus 1 plus 10 plus 1 is equal to 15. And if we divide it by 5.
I make an error.
Right. Okay, so you see it already, right? So the mean here is 3.
Yeah, so okay, we have take the other one and carry on the other side, please.
Okay, sure. So let me rearrange this so that we have, a 10 and a 1 and a 1.
Yeah.
So, okay, so the mean is definitely 3. I agree with you. The problem with the median here is I'm not allowed to just rearrange the data however I want, right? I mean, if I write the data like this, I can't just say the middle entry is 10 and that's the median. Because for the median, I always have to arrange from smallest to biggest. So
Yeah,
in this case, I have to arrange it like that. And the median in this case is going to be equal to 1, right? So
sure.
This would be the mean. So this doesn't work, but it's a good try. And what's Gabriel's idea? Gabriel's idea is you got to throw in some stuff that's much less than 10, right? That's the only way you're going to bring the mean down. But the problem is if you want to keep the median to be 10, anytime you put in something less than 10, you also need to put something in that's greater than 10, right? That's the only way the median will stay 10. So this is a great first try. So now we're going to try again. And my hint is you're going to have to use negative numbers to make this work. Okay, there's no way to do this using only positive numbers. Yeah, as James says, either ascending or descending, right? Both are okay, and both will get you the same answer for the median. So yeah, so that's correct, what James says there. So let's try again. Okay, so let's say we need to put something very small on the bottom and something big on the top. And so let's maybe even focus our effort. Let's try to have only 3 data entries. Okay, so 1 below the 10 and 1 after the 10. So for the mean to be 3, we need the sum to be 9, right? If we're going to have 3 data entries and we want their mean to be 3, then the only way to do that is to have the sum of all of the data entries be 9, right? Because 9 divided by 3 is 3. So how can I throw in 2 more data entries with the 10 in the middle that makes the sum 9? What's one way we could do that?
You say what? Come again?
Yeah, so can you come up with a data set with, let's say, just 3 entries, a 10 and 2 more entries, 1 below the 10 and 1 above the 10. As long as I have 1 below the 10 and 1 above the 10, the median will be 10, right? But I want the mean to be 3, which means we need the sum of the data entries to be 9. Okay?
Yeah.
So what's one way that I could complete this data set so that I would have a mean?
So, yeah.
Yep.
Yeah.
Yes,
that
Christopher?
So I can take negative 6 before 10.
Yep.
And I can take 5 after.
Well, again, remember, we can't take 5 after 10 because the 10 is going to be the biggest then, right? We can't just put things before and after. It has to be something less than 10 and something bigger than 10.
Oh, yeah. Okay. Hello.
Yes.
Hello, sir.
Yes, hello?
Yeah, can we say negative 10 and then 10 after the 10 don't put 20?
Well, if I have a negative 10 and then a 10, then everything's going to add up to 10. I need everything to add up to 9. So you're almost there. You may need one little change. Instead of negative 10, use what?
It's on negative 10, don't use negative 5.
Right. Well, if we want another 10 here, what needs to be the first entry?
Negative 9.
Remember, we need them to all add up to 9.
Yeah. That's not negative 9.
Negative 11, right, Ed? Thank you. So this will work, right? Negative 11, 10, and 10 will work, right? Because in this case, we have that the median is equal to 10, the middle entry, and the mean is going to be minus 11 plus 10 plus 10 divided by 3, which is equal to 9 divided by 3, which is 3. Yeah, so it's a little tricky to do. You really need to throw in something that is very, very low for that to work. And maybe the important lesson from this is that when you're doing the median, you can't just place things in whatever order you want. It has to be in ascending or, as James said, descending order. So you can't say a minus 10 and then a 10 and then a 5, right? Things have to be in order, either completely increasing or completely decreasing in order to be able to calculate the median. Okay. So this is one answer. There's lots and lots of correct answers here. You can do lots of different things, but this is maybe the simplest answer that you can do. Okay, any questions on this?
Wow, I think this is a good concept. I think it brings about creativity. You got to think outside the box, not just in the variable, but being creative and try error methods.
Thank you. Yeah, no, I agree. And so you can try to find other answers. Find other answers with smaller data sets, with bigger data sets, whatever you'd like to do.
Yeah.
All right. Any other questions or comments? Okay, so let's do another problem that will, okay, so this is a little bit at what I forgot who was asking earlier on. Ed maybe was asking about. So let's say that we have 25 students with a combined average of 70 on a test, and another 20 students have a combined average of 80. Okay, and we want to find the total average for all 45 students. Okay, now that doesn't mean the 25 students each got a 70. It just means their average is 70. But I claim what we have here is enough information to find the total average for all 45 students. Okay. So I'll give an idea, and then maybe I'll let you give some of your ideas. If we can find the total sum of the scores of all, if we can find the total sum of the scores of all 45 students, then we can answer the question. Right, because if we can find the total sum of the scores for all 45 students, we just have to divide it by 45, and that will get the average. Yeah, Dalman?
Yeah.
Sorry. So total sum will be 75. Okay, remember, that's probably not going to be the total sum, because when I say the total sum, I mean all 45 students, and you add up all of their scores. So that's going to be higher than 75.
Yes,
so, sorry.
150.
Yes, Christopher?
Yeah, so for the 25 students,
yep.
For the 25 students, the sum of their average will be 1750. That is 1,750.
Right. So the sum of the first 25 students, right? How do we figure this out? I mean, so you're completely right. Let me just write what you were doing, right? So we know that the average is equal to 70, which is equal to the sum divided by 25. And so this tells us that the sum is equal to 70 times 25, which is equal to 1,750. Great.
The same is done for the 20 students. So it's 20 times 80. It's 1,600.
Exactly. Great. So the sum of the next 20 students, exactly, right? So is similarly is going to be 80 times 20, which is 1,600.
That will give us a total of 3,350.
Great.
Then
So
we
the
now
total
divide by
sum,
45.
exactly. Fantastic. Thank you. So 1,750 plus 1,600 is going to be 3,350.
350 divided by 45.
Right. And so what is that? 33, somebody has calculator, 3350 divided by 45. That's going to be, trying to do this in my head, 670 divided by 9. So this should be 74.444, something like that. Is that right?
Yeah.
Let's see. Let me check myself.
335 by 45. Let's see.
350 divided by 45. Yeah, okay, I was right. Okay. So
Yeah.
so this is going to be a 74.4. Okay.
Yeah, that's correct. 74.4.
Okay. So 74.4. So we saw William with the original idea that the total sum will be 75. That's a very good guess, right? Because you've got a bunch of people with a 70 average and a bunch of people with an 80 average. So when you combine them together, you would, yes, it's a repeating decimal. That's the bar above the 4. This means the repeating decimal. So when you combine them together, you'd think that the average would be between 70 and 80. So 75 would be right in between. But the point is here that you actually have more students with a 70 than who have the 80. So what you're actually doing here is what's called a weighted average. We'll talk about that next week when we do the frequency classes and averages. But because you have more students with a 70 than with an 80, or more students who average 70 than who average an 80, you're going to have more, sorry, why can't I, what happened to my mouse? What is going on here? Sorry, my computer's doing something weird. Because you have more students with a 70 than an 80, you have more students. That means the average should be a little closer to 70 than it is to 80. And in this case, we see that it's just a little bit closer to 70 than it is to 80. It's not 75, which is right in the middle, but it's a little bit closer to the 70. It's 74.4. Okay. All right. So any questions on this problem? William?
Yeah, thank you so much for clearing my doubts. But I thought I would just add the both 70 and 80 to give you 150 and divide by 2 to give you 75. But now you clear my doubt. That's correct. Thank you.
Right. So that you're welcome. So that would be the same if both groups of students were the same size. But because this one's bigger, it's going to pull the average a little closer to 70. So that's what happens here. All right. Other questions? Okay, so let's do one more problem. This is probably the last one we'll have time for today. I also want to talk a little bit about other kinds of means, but we won't have enough time today for that, so I'll save that for next time. So the arithmetic mean of 12 scores is 82. When we remove the highest and the lowest scores, the new mean becomes 84. Okay, so by the way, this is something that people often do. Instead of calculating a mean, you calculate a mean after you take out the highest and the lowest, or after you take out the 5 highest and the 5 lowest. This is what's called a trimmed mean sometimes, and it's another way to try to get rid of outliers in your data set. You drop the highest and the lowest score, or some number of highest and lowest scores, and then you take the mean of what's left. Okay, so when we do that, the new mean becomes 84. So I say if the highest score is 98, then what is the lowest score? Oh, why is this? So maybe I'll give everybody a minute to think about it. I have to step out for a minute or two. So spend 1 or 2 minutes thinking about this, and then I'm going to come back and we'll discuss the question. Okay. Okay. All right. Anyone have any ideas how you might start to approach this problem? It's a little bit tricky. It's not a straightforward problem. It is a few steps to solve this. Anyone have an idea?
Yes, that was.
Yes, Christopher?
So I can't say I have my idea did not go further, but let just how I started up.
Okay.
Just the start up.
Yep, sure.
So for the arithmetic mean of 12 schools to be 82, and I say the sum of the schools would be 12 times 82, just like the previous one.
Okay, so that's fantastic, and that's exactly how to start. So sum of the scores is 12 times 82, which is what?
984.
Okay, great. Okay, that's exactly how to start. That's perfect. Okay, so the sum of the total scores is 984. Great. So what's next?
So then I said when the highest and lowest scores are removed, so that 2 scores being removed from 12, so that left me with 10.
Right.
So that would say sum of the 10 scores remaining would be 10 times 84. After removing lowest and highest.
Okay, so after removing highest and lowest, the new sum is 10 times 84, which is
840.
Great. Okay, so this is perfect so far. So where do we go from here?
Somebody has their board dress.
Yeah.
So I was thinking whether we could find the sum of the total schools. I don't know, 984 and 840.
Right. So what does that mean? We got rid of the highest and the lowest scores, and we went from 984 to 840. So
excuse me, sir.
Yes, Daman?
Okay.
We already have the highest score.
So the lowest score will be 84.
So to get the lowest score, you minus 840 from 984.
Right.
Okay.
You minus 840 from 984.
Right. So
then
highest plus
the
lowest.
Highest score from there.
Right. So it's 984 minus 840, which is 144, as Daman said, right? Okay, great. So Daman, do you want to finish it up?
Yeah. To get the lowest, 98. I mean 144 minus
46.
88. I mean 140.
Right. Great. So the lowest, right. The highest plus the lowest is equal to 144, and the highest is 98. So the lowest, right, 144 minus 98 is going to be
46.
46. Perfect. All right.
Yeah.
Great. Yeah, so it's multi-step. It's a little bit tricky, but you have all of the information you need, and this works, right? So the key is anytime you know something about an arithmetic mean, you also know about the total sum. And usually for these types of problems, it's easier to work with the total sums directly than to work with the arithmetic mean. So in this case, we just need the total sum for all the scores. Now the total sum for the middle 10 scores, so not the highest and not the lowest. And by subtracting them, 984 minus 840, we get the total sum of just the highest and the lowest. And so we also know the highest is 98, and so that means the only choice for the lowest is to be 46. So this is great. Okay, so thank you, Christopher and Daman, for your solution and for working together. Okay, any questions about this problem?
Yeah, I have a question.
Yeah, Daman.
Is there any other method you can use besides this method?
I would think any other way to do it would be more or less equivalent to this. I mean, maybe there's something else you can do, but for me, this method is the only way I would think to solve the problem. Maybe there's some, I don't want to say there's no other method to use, but for me, this is how I would solve the problem.
Okay.
Yeah.
Thank you.
You're welcome. Other questions? Okay, so there are some other measures of central tendency. We're not going to have time to talk about them today, so we'll do this all next week. Okay, so there's something called the geometric mean. There's something called a harmonic mean. There's various inequalities that hold between these two things, but we're going to talk about them next week. So for homework, don't do homework problem number 3 because it relies on the geometric mean. We'll talk about that later on. So here we have a basketball player scores an average of 18.6 points per game for the first 5 games. How many points must he score in the 6th game to raise his average to 20 points per game? I get versions of this question from my students all the time. They've taken, 3 tests and they have the scores that they have, and they'll say, what do I need to get on the 4th test in order for my average to go up to an 80 or a 90, in order to get an A or a B? So this is that type of question that can help a student figure that out. So this is number 1. And then number 2 is another one of these open-ended questions. Can you construct a data set that has mean 10, median 20, and mode 30? And I'm just going to, maybe I won't say anything. Okay, mean 10, median 20, and mode 30. And I'll say again, you're going to need negative numbers for this. And then, so let me just say next week, we'll do more on measures of central tendency. And we'll begin measures of dispersion, which includes the range that James mentioned earlier on today. Okay, and next week we'll be back to our usual meeting time, meeting at 4:30. Okay, any questions from the stuff from today? Okay, so if there's no questions, I do unfortunately need to leave because I have to walk to a meeting a little bit further away at 1. But thank you for coming. Thank you for participating. I'm going to stop the recording.
Yes,